Welcome to this presentation on customer success on Azure SQL Database. My name is Sunil Agarwal. I'm a program manager with SQL Azure Database team. I've been with SQL Server team for the last 16 years. And I had a good fortune to work with Avinash on Bing Ads migration to Azure SQL Database, as well as Ghana from Dynamics AX team on their journey to Azure. So in this presentation, they will share their experiences with Azure. How did they start? What motivated them from migrating from on-premise to Azure, their journey, challenges along the way, and how they are successful with Azure SQL Database on our platform. So in this, I have a very simple agenda. For the first 10 to 15 minutes, I will focus on migration on Azure SQL Database. And then Avinash come on podium, and he will talk about his journey with Bing Ads. And then Ghana will follow that. And if you have questions, please feel free to ask. So this is me. So let me start with Azure database migration. So I have worked with many customers in SQL Server, and you won't be surprised if you go back 2-3 years ago. Pretty much most customers were running their workload on premise. So when you run your workload on premise, people have done it for years and years. There are challenges. First of all, the first challenge is the hardware acquisition, right? You have to buy hardware by predicting what is the capacity you need, what kind of capacity you will have for your workload demand, say 3 years from now, because hardware cycles are 3 years or 4 years, right? And that is also like guesstimate. It's not always perfect. And many times people buy hardware in a more conservative way. So they are buying hardware and it is not being used to the full capacity because they had to buy for the maximum throughput workload that could happen in the next 3 years. So besides having the hardware, they actually are responsible for backups, high availability, security, performance troubleshooting, all kinds of things which are not the core to their business. The core to their business is their application, not the database. But when they were running on premise, you need to deal with these things to make your application available to their customers. So the first journey a lot of customers have taken is they move to a virtual machine in Azure lingo that is called IaaS, Infrastructure as a Service. And what you see here, that with virtual machines, you move away from purchasing the hardware or the data center because virtual machines are hosted inside Azure. You can scale up and down, so you don't have to worry about if the workload capacity increases in future. You can scale it up and things like that, right? So you move away from that. And high availability implementation, Microsoft Azure provides that right off the bat. So it is all set. You can, when you provision a virtual machine, you can provision a virtual machine with always on. So those kind of complexities have been simplified, but you are still responsible to make sure you do the backups, right? You have to worry about disaster recovery scenarios. You have to worry about security compliance. All the things that you were doing on premise, they stay there. The only benefit that you got is you moved away from purchasing the hardware. So this is where the Azure SQL Database comes in, which is we call platform as a service. That's the offering. And the beauty is it takes care of everything that I had listed for the first 2 columns, right? It has built-in SLA for 99.99 high availability. You don't have to worry about backup restore. It has advanced threat protection. We will secure database automatically because you're running on database as a platform. And it has a very rich set of telemetry that we present to our customers, so they can look at that telemetry to figure out how their workload is performing, and they can fine-tune it. And in many cases, we have made that tuning automated. You can set some flags, and we can automatically tune your workload. So that means your organization can focus more on the application rather than nitty-gritty of maintaining the database. So that is the Azure SQL Database power. And if you know, Azure SQL Database, the PaaS service comes in 3 flavors. The first flavor, this is the first one that we came out with, is called Azure SQL Database Singleton. As singleton implies, it is a single database. So from your perspective, when you provision your Azure SQL database, Microsoft will give you one database, that is your database, and behind the scene, we are managing that database from version upgrades or backup, restore, everything that I talked about, but you have a single database. So all you have to do, provision the database, upload your database content from on-premise to that, and for that, we provide a tool called Database Migration Service that can take your data from on-premise to Azure SQL Database Singleton with minimal downtime. So your database data comes there, and now your application should run as before, right? It is as simple as that. But you will notice there are some surface area limitations in the Azure SQL Database Singleton. Namely, I'm giving some examples. This is not the full list. The CLR, if your application was using CLR on-premise, and if you wanted to migrate that database to Azure SQL Database, it won't work. You have to work around that part, right? CLR was not supported. Cross-database transactions. A lot of applications that I know are multi-database applications, right? It's just not one database. So if you have queries in your application which is accessing multiple databases, that will not work inside Azure SQL Database Singleton. For now onwards, I'm going to call it Singleton. So it won't work there, right? So that means that that's a limitation. And that means either you have to change the application or you cannot migrate, right? There are some limitations like that. So for that reason, there were some customers who wanted to migrate to Azure SQL Database but could not do because they could not change their application, right? The second flavor of Azure SQL Database is called Elastic Pool. Elastic Pool, the way to think about is, it is Azure SQL Database Singleton, but what we have done is we have pooled multiple databases together. And the benefit is this, that if your database workloads have different peaks and valleys, right? I mean, not each database is peaking at the same time. What you can do, you can allocate some compute and the storage to the pool of databases. And since they are peaking at different times, so they can use a common set of pool of resources to lower the cost. And this has been a very successful deployment of Azure SQL Database. In fact, I'll give you one example. Microsoft Dynamics CRM, they have been using Azure SQL Database Elastic Pool in a very prominent way, and they have been very, very successful with that, right? Still, if you look at the surface area limitations, they remain the same because Azure Elastic Pool is nothing but singleton database, except it is being managed as a pool, right? So the third thing that is we are really excited about, you must have heard about that in the conference over and over again, is called Azure SQL Database Managed Instance. As the name implies, it is not a single database. It is an instance of SQL Server. And some of you may not know what instance is. When you install SQL Server on your premise and you start SQL Server, that is an instance. It has system databases like master database, tempdb, right? And it has one or more user databases, right? This is exactly what you have on premise. And this is exactly what we are providing you as a service. Now, the beauty of this one is it makes the migration of your application from on-premise to a PaaS service much, much easier because you have exactly the same scenario. And if you look at the surface area limitations, I've crossed out, like if you look at here, I've crossed out CLR, cross-database transactions, linked server. A lot of these limitations that were there in Singleton, they have been removed. Some limitations still remain, for example, file stream and polybase, and that is just point in time. We are working to address those limitations as we move forward. And you will see the customers that I have, Bing Ads and Dynamics, they started their cloud journey much before managed instance came along, okay? So they worked with Singleton database and Elastic Pool, and they worked around those limitations. But if they had to do it today, managed instance would be their first choice for the migration, and they will talk about the challenges they had. So now I just want to briefly touch upon how I have seen customers migrating their workloads or their cloud journey from on-premise to the cloud. So what I'm showing you here is a very sort of a generic, a three-tier architecture that you will find in an application. You have a presentation layer here, and then you have a load balancer. I mean, if you have a lot of clients, which is a very common case, you have a load balancer to route the traffic correctly. Then you have an application tier, and this is the data tier. This is typically like a SQL server. This is how people have it on-premise. This, what I'm showing you with the gray, is your on-premise environment. So now let's say you're sitting here, and you want to go to the cloud. So what can you do, right? Anybody in the cloud yet from on-premise? Not yet. OK. So suppose you want to go to the cloud. The simplest thing that you could do is you can move to the virtual machine under IaaS, right? You can move. So what I'm doing here is that you see something in orange here. I created 3 virtual machines, right? Virtual machine 1, 2, and 3. It doesn't have to be 3. It could be just 1. And you can use a tool that Microsoft provides right from our tool set called Azure Site Recovery. It can migrate your on-premise environment exactly to Azure virtual machines. And then once it is moved here, you can get rid of your on-premise environment, right? In this case, the benefit is it gives you the full flexibility because you have the full control of the machine like you had on-premise. Same version, whatever you want to install, this is your virtual machine, but you are responsible for everything I talked about before, right? Now, once you reach to this level, you may want to leverage Azure SQL Database that I just talked about to simplify the management of your database tier. So what you could do is you can use Database Migration Service, DMS, which is GA a couple of months ago. You can move that, use that service to move your SQL Server running in a virtual machine to Azure SQL Database. So now the benefit is you don't have to worry about managing your database, right? And your application run as is. And what we have seen is that DMS allows you to migrate database in a very online way. And once the database has been migrated, all you need to do is change the connection string from, in this example, to this virtual machine, SQL Server, to this managed instance thing, right? And application just works fine. So this is one journey that we have seen for customers who have their applications and want to take advantage of PaaS offering. And Bing Ads is in this category. They have actually migrated to this configuration. Now, Dynamics AX is a very successful ISV offering from Microsoft. They are a ERP workload, and Ghana will talk about that in more details. So what ISV customers are saying, you know what? ISV customer says, I don't want to buy the application. I don't want to install the application, host it, because my business is the application, not the infrastructure behind it. So could a ISV not provide me my application as a service? You must have heard about SaaS, software as a service. So question is how ISVs are adopting SaaS model in Azure configuration. So again, that is a journey, okay? I'm going to touch upon that point. So what do they do? At one level, ISV can say, you customer, you were running everything on-premise. Let me take the whole configuration and host it for you in Azure, right? This is exactly like what I was showing you in the slide here, right? This is how you're hosting your application in the cloud. Now ISV can say, I'm going to host it for you. So I'm hosting this for customer 1, right? So you could notice I have a load balancer if I need. I have application tier, and I have data tier, right? Exactly. And I'm still make it easier for me because I'm using PaaS service, right? OK. Now customer 2 comes along and says, I also want my stuff to get hosted. As an ISV, I create another environment. Now you can imagine if I have tens and hundreds of customers, this thing becomes very expensive for me, right? This thing becomes very expensive for me. I'm just going to make sure my mouse is coming. OK. So the thing that you see here becomes expensive because I'm maintaining the whole stack for each of my customers, right? So, but this is the first easy step to provide software as a service. And then what customers are doing, ISVs, they are migrating their app tier, which I showed, to a multi-tenant application. Here what you see is a multi-tenant tier. So now what happens is you can host multiple customers with the same application, right? In fact, you can even move this data tier in some cases to Elastic Pool, and each database in the pool can reference one customer, right? So what I'm saying is moving for an ISV to provide their customers a SaaS offering is a journey. The left thing that I showed you is an easy way to do it, but it is expensive. But over time, you can migrate your workload to change your application. This requires a lot of work, re-architecture of the application. It can be year-long, depending on the complexity of your application. It can be, year-long, 2-year-long kind of investment. So that's all I wanted to talk to you about the cloud journey. Now I want to invite Avinash on their cloud journey for Bing Ads. How did they take their on-premise workload and made it successful on Azure SQL Database? Avinash.
Thank you, Sunil. Hey, folks. Hi. Welcome to this session. My name is Avinash Jaiswal, and I'm a data engineer at Microsoft's Bing Ads organization. I'm here to talk to you about my story, my team's story about migrating from on-premise SQL Server to SQL Azure. We'll be talking about how we did this journey, what challenges were we facing on-premise, and what solutions we came to move from on-premise to Azure, and what benefits we are seeing as of today. I'm confident that after this session, you will move to SQL Azure because we are seeing a lot of benefits. So let's quickly go over the agenda of my part. So first thing which we'll be doing is we'll see an overview of my analytics platform, and then we'll see what are our motivations to move to SQL Azure, and then we'll see how we handled those challenges which we were facing during this migration phase, and then we'll go over the post-migration benefits and some learnings and recommendations which we have as a result of this journey. So let's quickly go over an example. So what here I have is, I wanted to give you an example of my Bing Ads application. So what I have is an example where, say you are searching for a camera, in this case a Nikon D850. So what I do is I come to the Bing homepage and I search for this camera. On the screen what you see is the search result returned from Bing. If you notice closely, there are two components to this search result. While the majority component is the actual search result, what we have is the first item in the list is an advertisement which Bing Ads shows. And now if you click the ad, Bing Ads will make some money, right? Bing will make some money. But if you do not click it, that's when we get an opportunity to analyze what went wrong or how can we improve our system so that we can make more money and show you more relevant ads, and hopefully will make your experience much better. So for all such analytics, the Bing Ads team is highly dependent on the Bing Ads analytics platform team, which is my team. And so if you see the components here, I have highlighted is the search query which you have. This is what you are searching for. And then the advertisement. So these are the things which we analyze and its various properties. So what kind of analysis do we do? What we provide is an interactive platform, which is a UI-based application for our internal users. And what you can do is come to our platform and search for data, or ask for various metrics like, hey, what was the total revenue? What was the top queries in the last 1 year which users searched? How are we doing in certain markets? Are we doing well or are we doing bad? What were the number of clicks and things like that? Now, our users expect this platform to be as interactive as possible, and the response time which they expect is, it has to be very fast. So in our case, almost most of our queries are returned under 10 seconds. And if you see 95th percentile is under 1 second. So the platform has to be really interactive and fast. We do support slicing and dicing of dimensions. We have multiple dimensions across which you can ask for the data. And the biggest problem for us that, hey, we need to be interactive, but the data volume is very high. So that's a big challenge. We have multiple years of data, and the total database size is greater than 50 terabytes. And we load loads of data every day. Now, what I want to show is what is the architecture of our Bing Ads Analytics platform. So this is a very simplified representation. What we have is that once the user clicks, all the logs from the searches for something on Bing, all the logs are generated, and what we have is an internal ETL process which processes the logs and then puts the data into our data tier. We have a presentation tier and an application tier which talks to our data tier to show the results. Now, given the large volume of data which we have and the fact that we want our response time to be interactive, my team heavily depends on SQL Server to show the results. Now, since our focus here is SQL and the data tier, what I'm showing to you is, this is my, what challenges we had with on-premise. This was on the on-premise. So what we had was, throughout the year, to scale horizontally, what we had done, we had created multiple databases. And now these databases were kind of in a scattered infrastructure. They also had multiple SQL Server versions because of silo developments at times, or because we were scaling out. And we have a small team, and our primary focus is to build the application and not completely always manage the database architecture. So we were facing all these challenges. Also, in our infrastructure, we had cross-database queries, like, hey, one database talking to another database, and we had large databases in our system. Some databases were like more than 15 terabytes in size, and we also had Cube. The operational overhead also was very high for our team. Why were these operational overheads there? Because this is on-premise infrastructure, and we need to take care of all the aspects, administration aspects of the databases, like upgrading the SQL Server, or say monitoring the disk space, and taking backups and things like that. And we were finding hard time. So we knew that, hey, let's move to SQL Azure, because that's our cloud offering of SQL, and can reduce some of our worries if we move to SQL Azure. So why did we decide to move? The biggest reason why we wanted to move to SQL Azure was that, hey, it required the minimal application changes. It was the same SQL Server technology, but it was hosted on cloud. So for our team, the work required to move would have been less. Also, you could have scaled it anytime. So if you need higher performance, or if you need more storage, you can do it dynamically without seeing any downtime on SQL. Now, mission critical availability is also very critical for our team. We want the data to be present for our user all the time. And SQL Azure provides high availability with a 99.99% availability guarantee, which makes it easier and trustworthy for us to move to SQL Azure. Also, it takes up backups automatically, so we don't have to manage those parts of backup. And say if something goes wrong, we also have the opportunity to do point-in-time restore. So that's a big advantage. Now, what we have seen is that SQL Azure also provides automatic upgrades behind the scenes. So that means we will always be on the latest SQL build, irrespective of when you created your database. SQL Server will work hard, SQL Azure will work hard to keep your SQL bits up to date, and this helps us to leverage the latest advancements in SQL technology. Now, let's go over some of the challenges which we faced during this migration, because we knew that there are certain advantages of moving to the cloud. and now we want to move from on-premise to cloud. So now this was the biggest challenge for us. Now what we had was our largest table size was 15 terabyte, but Azure SQL singleton size limit was just 4 terabyte. So the solution to that, which we had was, hey, the obvious solution was let's shard the databases, right? So that you distribute the load and then you can move data in multiple databases. We tried sharding, but in our case, the performance was very slow. So this was not a good solution in our case. So we turned on to leveraging the latest enhancement in SQL Server, basically clustered column store index. This helped us reduce our data volume and also increase the performance of the database. Now, since we were able to increase the performance, one more way to reduce our data size was to eliminate the other redundant or say not required row store indexes which we had. So we were able to eliminate that. And for the existing indexes which we had, we applied page compression, which compressed our data further. Now the result of this was that our final data volume was just 2.5 terabyte, which was enough for us to move to SQL Azure. Now, another big challenge was cross-database queries, and SQL DB did not support it. So to solve that problem, what we did was we merged our databases into a single database so that we can get over that problem. Now this required us to make schema and ETL changes, but overall this was something which we could have used to overcome the hurdle of migration. One more thing which we faced in our day-to-day life was slow data load during our ETL process. This was because of high data volume which we had, and traditionally we have a fixed retention period, so we want to get rid of data also. We want to delete old data and insert new data. So both deleting data and loading new data is something very important for our aspect, and both were taking long time. So the solution for this problem was to partition our tables in a daily partition level so that you can load the data in batches. You can load the data in the staging table, and then you can simply switch in the partition when that data is ready. Table partitioning also helps you to delete data because very quickly and efficiently, because you can simply truncate a partition rather than saying running the delete command, which takes a lot of logs, and it takes long time to delete. Now this is how we overcome our slow ETL process. One point to make here is this could have been done in the latest SQL Server on-premise version also, but the fact that we were migrating to SQL Azure gave us an opportunity to leverage the latest technologies and also to improve our own database infrastructure. So we utilized this technique to improve our ETL challenge. Now, how did we go ahead and do the deployment? So we made all the schema changes in the database project. We tested it in SQL Azure. And after we were done testing, what we did is we deployed our database project using SQL Server data tools to Azure. For moving the data migration services was still not mature. I'm talking of early 2017 and say mid 2017 when we were doing this migration. So we used BCP to copy our data into files and then upload it into Azure. We found this method to be efficient enough for us, and that's how we migrated our data. Now, regarding the presentation and application tier changes, for our case, we did not require any such change. All the changes which had to happen happened in the ETL layer and the data tier. So our final change during the day when we were moving on to our SQL Azure was that, hey, we changed our connection string, and we faced no downtime also, because that's the simplest change you can do online. Regarding the timeline, assessment, testing, migrating it, and then optimizing it, which was a very, very critical part, took us 3 months for our whole platform. Now, I want to take a step back here and show you this was our on-premise architecture. And now after we moved, this is our SQL Azure infrastructure. If you notice closely, the only thing which is changing in this case is the data tier and some of the ETL process which we had to change. Now, recall the challenges which we faced in our on-premise layer. Now, the challenge of multiple scattered database infrastructure was solved because we had just one single logical server in which we installed our databases. We created all the databases there, so we could manage it very well. We also clubbed multiple small databases wherever the load permitted. Like as Sunil mentioned, we also have scenarios where there are peaks and valleys in our data load. So we clubbed smaller databases into elastic database pool. This helped us save money and also improve performance in cases. We merged our database to eliminate the cross-database queries. Now, if you recall here, we have a cube. So what we did is, since we were migrating, we took this opportunity to get rid of the cube by simply having a database with a clustered column store index. In our case, the clustered column store's performance was good enough to meet our SLAs, and so we were able to get rid of that. This saved us a lot of time even in the ETL process, because if you know how cubes load data, after you load your data into the databases, the cube processing starts, and it takes long time to process the cubes. So for our case, even our SLA were reduced, data availability SLAs. Now we have migrated to SQL Azure. What are the post-migration benefits which we are experiencing? The query performance has improved 10 times on an average. Now, I have stored procedures and calls which were taking literally 5 minutes, and many of them return in under a second at times. Now, this is not all just because we moved to SQL Azure. It's also because we took this opportunity to improve our system. But SQL Azure has helped a lot. Storage reduction, more than 70%. A lot of this is credited to column store indexes. Since we have been on Azure SQL, we have seen a zero downtime in SQL Azure. There has been literally no downtime. The connection has never failed for us. Operation overheads. We have been able to reduce our operational overheads by more than 50%. Right. Earlier, we used to do all the disk monitoring. You have to take backups and things like that. But right now, all that headache is gone. And this aspect is very critical for a small team as what we have, because now we can focus more on building the application and cater to our customers' need rather than focusing on the database administrative parts. Now, some of the learnings and recommendations which we have for as a result of this migration, that we highly recommend people to move to SQL Azure wherever your limitations are met, if that allows, because it reduces your operational overheads, and the scalability scalability is also improved because now you can scale your system on the fly. One thing I would recommend highly is to try and test the latest SQL database features and offerings. These offerings are also available on on-premise SQL Server's latest versions, but since you are migrating to Azure, it's really very important or it could be very useful for your case to check out these features. column store indexes, query store for query performance monitoring, and so many other features. You really need to test it and optimize them also. Now, the biggest thing which I have learned is that time flies in the cloud faster. We started our migration in 2017 and we finished in 3 months, right? But still there were a lot of manual processes which were involved, which makes the journey a bit difficult, though the destination is amazing. As of today, the same problems could be solved in a much easier way. For migrating your database, you can utilize database migration service, which makes it really easy to migrate your database. SQL managed instance is there. This solves a lot of problems like cross-database infrastructure problems, or say modifying the schema, and a lot of other compatibility issues could be solved. So given today, we will move to SQL managed instance if I had to do it today. Also, the size limitation problem which we are still facing on the singleton will be solved as soon as the Azure Hyperscale, SQL Azure Hyperscale is GA'd. So those problems of size limitations will also be solved. So that's it from my side, and I call it.
Let me unless there's a question from the audience, let me tell a couple of things which are important. Hyperscale is something that we announced in the keynote on Monday. It is in preview, and what Hyperscale gives you is a unlimited storage for Azure SQL Database. We have tested up to 100 terabytes, but architecturally there is no limitation. So essentially that was one of the challenges when I was working with Bing Ads team, that okay, column store compression made it 2.5 terabytes, but I'm still afraid because my workload will increase and my data size will increase. I may hit the limit of 4 terabytes, then what do I do? And with the advent of this hyperscale, I think they are feeling very comfortable that when they need more than 4 terabytes, they can leverage the hyperscale to achieve that. And I think the thing that I want to summarize, the managed instance is our new offering for Azure SQL Database, and the target is lift and shift. So for example, the cross-database transaction thing you just talked about would not have been an issue there. And so yeah, it makes migration very, very easy.
Right. Yeah. And one thing which I recall, like since we were talking about, when I talk of Azure Hyperscale, so it will be very easy for us to move from a already database which is in Azure to Azure Hyperscale.
That's
and right now when I talk of reducing operational overheads, one thing which we have been feeling good is that if you want to do any experiment, you can simply copy database online, right? And earlier you have to do a lot of administrative tasks to copy your database and do your experiments. So for all such things, even our development cycles have improved a lot. Now we are able to deliver more features faster because our experiments are faster.
Outstanding, outstanding. Yeah. Thank you. Any other question from audience? No? Okay. Thank you, Avinash. And now I'll request Ghana to come and talk about Bing Ads. Dynamics, I'm sorry.
Dynamics 365 Finance and Operations. And I've been working with the Dynamics 365 for over 12 years, and pretty much on the role of the performance lead and the performance manager. And here, I'm here to just talk about how our journey of taking Dynamics 365, previously it's called as Dynamics AX, to the cloud. And to level set, so I have to just talk a little bit about like what Dynamics 365 is and what kind of application it is, and how did we manage to take this to the cloud, right? And it's not like, okay, the journey without any hurdles, and we have to carefully handle, look at the problems and evaluate the problem and look for all the possible options, how we can jump over the hurdle and choose the things. To start with, I'll just want to show you this. This is our loading page for Dynamics 365 Finance and Operation application. So when you log in, this is what you will see. So the variety of icons shown here, that tells the breadth and width of this application, right? It's an enterprise application. It covers like pretty much all the key components a business application needs, an enterprise business application needs. For example, if you just take financials, it has general ledger, it has accounts payable, accounts receivable, costing, fixed assets. So pretty much it covers the entire wide range of financials. Then it spans to like, sales, purchases, and production, manufacturing, MRP, and retail, right? All this business applications, business functions, that's all supported by this. So whatever it's just I listed here, that's just a small set of the available functionality in this particular one. So for this to work in a precise manner and run your company's business, right, it needs a lot of components, isn't it? So this is the architecture from where we just came from, right? This is our old architecture. This is Dynamics AX 2012. The picture I'm just showing here, that illustrates the number of moving components in it, right? And so the message I just want to come out of this particular one is, it's not a small application, right? So it is not like, okay, you can just take a small component and put it on the cloud and say that, okay, hey, now I'm cloud enabled, right? This is a lot of moving parts. And also, this is a very rugged application. There are over 20,000 customers running their business on this. So this is a trusted, well-rugged application. So when we wanted to make this cloud move, when we want to move this to the cloud, we have to just make sure that, okay, their experience is not really anywhere limited. So they get the same kind of experience. And in fact, we wanted them to just get better experience. So also, as part of our cloud journey, we wanted to just make sure that, okay, some of the challenging components in the previous architecture, we wanted to make sure that, okay, they are addressed. And so we took an opportunity and evaluate all these things. And wherever we felt like, okay, there's an opportunity to improve, right? We didn't want to miss that opportunity, and we wanted to improve that particular one. So one of the pain points what customer had with this particular one, right? One is it's a very complex architecture. There are a lot of moving components, and they have to maintain everything. And also from the database side, right? It is not a small database footprint, right? So it's a large database, and many of the customers, their data size is in terabytes. And in fact, like if you just look at the data model, there are over like 5,000 to 10,000 tables in it, right? So it is not a mom and pop application, it's a large business application. So when we wanted to just take this to the cloud, we have to just make sure that, okay, we take care of the customer who's going to trust us with that cloud journey. Now, why did we do cloud migration, right? There are various other components, and the best reason is, right, so we wanted the customer to just focus their business on their core business needs, right? So if I'm a retailer, I want the customer to just focus the need on the retail business. If it's a financial industry, let them focus on the financial industry. Let them not bog down by maintaining the software, doing the updates, taking the backups, and ensuring that the backups works, and ensuring that the restore works, all the sundry activity just to make sure that, okay, hey, I'm covered from all the aspects, right? So basically, like, okay, just moving them to the cloud, it's going to allow them, it's going to just free them to just focus on their niche, which is doing their business, and take away just pain of all the maintenance and other things. And also, if you really look at the Gartner report, so we are the technology leaders. We are on the top quadrant. And we are the innovation leaders. We are the technology leaders. To just make sure that, okay, so that reputation stands. It is our responsibility to continuously innovate. For that, we have to just make sure that, okay, yes, we invest in the right strategy, in taking our product in the right line, as well as taking the customers along with that. So that's an important thing too. So I just want to give a quote from our customer, which pretty much illustrates my point, right? So it basically nails the thing, saying like, okay, basically it fits the bill because it's as a managed service. So they don't have to worry about all the other aspects. Now, this is our new architecture. So the thing I wanted to just say is, when we said, like, oh, this is a thing that we moved from the old architecture to new architecture, it's not putting our database into a cloud infrastructure. So there are a lot of other components. Every component has to natively move, right? And the other thing that we need to figure it out is the lifecycle management. So we need to take care, like, okay, a cloud deployment and continuous updates, and in a way, like, okay, so we have to enable all this, and we have to provide monitoring. And so all this needs to come as a package. And of course, database is a very key component in our entire infrastructure. So from the architecturally, database plays a key role because, like, okay, so we rely on the things. Our business logic's pretty much on the application that's on the top, and our Dynamics AX platform, which is the kernel, which handles the client, server, and integration and analysis and reporting. All that, it's taken care by that Dynamics AX platform. But the key component, going back again, is like, okay, pretty much we rely on the database, right? Because that's the very vital part for us. So when we decided, okay, yes, we have to move to the cloud, we have to find out, okay, what is the options that's available for us during our cloud migration. So at that time, it's about like a 2013, 2014 time, and I think like we started our cloud journey like a 2014 time, and probably like we have to make a very critical decision during 2016, right? We had like, okay, only few options available. The two primary options were like, okay, take the database as it is, and this is going back to Sunil's very first slide. As an IaaS, just put the database as a SQL Server database there, right? That's one option. If we just do that, what would have happened is now the Dynamics AX, right? Dynamics, which is Dynamics 365 Finance and Operation. So we own the responsibility of, not only we own the responsibility of like, okay, just running the customers, providing the facility for the customer, but also we now own the responsibility of making sure that, okay, this database performs well. This database, I'm just going to make sure that, okay, yeah, database backups are working, and all this like patching and other things. Now we have to do, because all we did is lift and shift this particular one and put it on the cloud machine. That's all we did, right? That's one option. It's going to work, but the problem is like, okay, from Dynamics 365 F&O, we have to have a team which manages these things. Now, the other option is trust that, okay, the upcoming Azure SQL Database, SQL DB is going to just help us, right, and do the things. So we weighed various things, and so one of the things, like, okay, I earlier said, if you are a retail customer, just focus on retail, right? We are Dynamics 365 F&O, our strength is that, and we wanted to focus on that, not on the maintenance of these things, right? If SQL Server is going to provide a native service, which is going to handle all this, and we wanted to embark on the journey and go with it, right? It sounded like very the reasonable option, and that's a reliable bet, we can make it. And also like, okay, there are other reasons we felt like, okay, yes, we have to do this. And that is like, okay, Azure SQL DB, that gave flexible sizing options, right? I don't have to like, okay, park the customer database on a SKU that's too big for them or too small for them. I can put them, and when it's needed higher SKU, without lot of moving wheels, we can move them to a higher SKU. So higher SKUs. So this journey, it's going to just give us a lot of benefits. The other point that's worth mentioning is fast turnaround times on fixes, right? And Sunil, or I think Sunil mentioned about how frequently we do the updates on the on-prem. So that on Dynamics, on the SQL Server, I think they release like, okay, every 2 years or something. But on the Dynamics, on the Azure SQL Database, it doesn't update every 1 month. So whenever there is a fix that's needed, whenever we need something, a new feature, new fix, that's going to just come in a very short period, and that's going to be available for all our prod tenants, right? Now we currently have over 2,000 customers online And these customers are big companies. It's not like small companies, they are running a small applications here, right? I can give few examples, like Macy's China, they are running it on Dynamics 365, right? And there are many other, like JJ Foods, and many other bigger companies, they are running their operations on Dynamics 365 F&O, so it's critical. So when we went like, okay, so I talked about like there are only two options, and there's a third option now available. So would manage instance worked for us? And yes. So after my presentation, you would know like, okay, some of the challenges we went through, and many of them already addressed by managed instance. And had we had the option of having a managed instance at that particular point of time, probably that would have given us towards like, okay, picking up the managed instance. So it would have been a good choice. Now, did our cloud journey, is it so smooth that, okay, we didn't have any challenges? No, there are lots of challenges, and some of them are very significant. So the thing I wanted to just start with is migrating the SQL database from on-prem to the cloud. So many of our customers, they have a large database, and they are running very mission-critical applications. And so, for example, I'll just tell you like how mission-critical it is. When they run their whole total business on this, right? Let's say it's a retail customer. So it's more like, okay, you just go to Walmart or you go to H&M, right? People are there, they bought a cloth, and they're waiting on the line to just check out. And if your scanner doesn't work, right, your system hangs, or your system says goes out of, it's a loss, it's a revenue loss to the customer. So it is like, okay, so there may be like, okay, a shipping company, the driver sitting there waiting for his packing slip to like, okay, delivered, so that, okay, he can take his delivery load and take it to the harbor or take it to the next warehouse. And if they can't print that particular one, then it's going to just queue up, right? So pretty much like, okay, let's say like, okay, he's a picker, like Amazon, right, kind of company. He's going to the warehouse, and he has to like pick items and pack it, right? He's going with this RF gun, and if that scan is not working, your system is not responding enough, so then basically like, he's holding his work, and he's basically like, okay, the company is like, the revenue at this particular point is at stake. So it is very mission critical that, okay, the system to perform and the system to perform well. So typically what happens during the upgrades, they will basically stop their pretty much the upgrades happens in parallel, but finally there will be a downtime by which they will stop their operations, and after the migration is done, they will start their application on the new hardware, right, on the new upgraded environment. In this case, the upgraded to the cloud. So let's say that, okay, I have a 24-hour window. So let's say like I stop my business on Friday evening for the upgrade to happen. So by Saturday evening, they have to start the thing. So pretty much that upgrade window is very critical for us to maintain. One of the things what we found is let's moving the large database from on-prem to cloud, just copying that thing. That was taking a lot of time. So we have to like, okay, find different ways to handle that. So we used like, okay, the backpack files. And one of the other things what we did is also like, okay, just bringing up a SKU that is much higher than what is needed, and try to run an upgrade as efficiently as possible. Then we can go down, reduce the SKU to the level that customer is really needed. So we want to just make sure these various options were available on Azure SQL DB, which enabled us to take advantage of all these options and make sure that, okay, so we provide the best possible experience to the customer.
So Ghana, let me make one quick point.
Yeah.
Like you mentioned about managed instance. So Azure SQL Database Singleton, you could not take a physical backup from on-premise and restore as a SQL DB Singleton. However, if the managed instance, you can take a physical backup and restore it as is on the managed instance. So if you have large database, the restore is much, much faster, as you know, from a BCP. So that would have solved that problem.
Oh, definitely.
Yeah. Okay. Thank you.
And The other thing is like, okay, when we migrated our database to SQL, Azure SQL, we experienced a lot of connection issues. So this got a lot better now. And still, the SQL might be doing some updates on the back end and doing a security patch or upgrading to the next versions. So during these times, we may experience a connection loss. So our application needs to be resilient to all this connection loss. So what we had to do is like, okay, when we noted that there was some connection loss that was happening, then we have to change our application code and during the connection manager and during the SQLs to make sure like we have a retry logic. And so that will actually, if it captures the connection error, then basically it will go on the retry so that, okay, the application will not be dead, the application connection will be retried, and as soon as the connection gets back, it will continue, right? So we have to make some amount of code changes for us to just make sure that, okay, so we work on the cloud. Database size is another problem, right? So when we started our journey, Azure SQL DB, that provided only like supported only 1 terabyte of storage. So the maximum size provided was 1 terabyte. And later it becomes like 4 terabyte. Now with the hyperscale, so we just don't have this limitation. But to start with, we started with on a time where they had like only 1 terabyte of database that's supported. So we have to just do something to just make sure that, okay, our large customers are fit in this particular one. So previously, we were not using the page compression, which was available for a long time. But we have to just make use of this now because, like, one, we find a need, and two, it's probably the best time where we can just make this kind of large changes. So we went and enabled page compression on our tables. So that reduced the database footprint quite a bit. As much as like, okay, it brought down the database size to as much as like 20% down. And so that was significant. And the other thing is like, okay, when we went to Azure SQL DB, for our reporting and BI needs, we had an SSRS running. And Azure SQL DB didn't support SSRS, so we have to find a way to handle the SSRS now. So we installed SSRS as an IaaS on one of our BI servers and use that for our reportings. And the last part I wanted to just touch upon is the latency issues that we have seen. So with the previous application, so if you are a D365 F&O customer, or like if you are a Dynamics AX customer, so you are familiar with this RPC thing. So previously, our architecture, we had a client component and we have a server component. So the code basically runs on the client and as well as on the server. And based on where the object got initiated, it maintains the references on the other tier. And that resulted in a lot of RPC calls, which is like, okay, pure overhead in terms of overall efficiency. So that was affecting the performance quite a bit. And so with our new architecture, we totally eliminated this. But also now it posed another problem. So previously, my application server and database server, they used to sit very next to each other. They are connected by a high bandwidth LAN connection, Ethernet connection, and absolutely there is no latency between my AOS and the SQL, right? Now, with the move of like just moving this to cloud, now there is a latency between my AOS. So when we try to deploy our, make a deployment, we ensure that, okay, both our AOS servers and the database, the Azure database, both are in the same region, Azure region. But still, there is no guarantee that, okay, they are going to lie next to each other on the same rack. So there is a latency. We found, okay, there is a latency between now the AOS, which is our app server, and the database. That latency is as much as like, okay, sometimes it is 0 milliseconds, sometimes it's as much as like, okay, 8 or 9 milliseconds. So if you're just going to make a million call, this 8 or 9 milliseconds, or even like 2 or 3 milliseconds, that adds up. So we have to just make sure that, okay, we architecture our application to ensure that, okay, there's no, we are prepared for this kind of latency. So what did we do? So we have to change our application somewhere, bulk up our, the way we just do the things. to reduce the number of round trips that we make. The second point that I listed out here is like, okay, bulking up the transactions. Now, previously, when I just do the commit, it actually commits. Now, in the Azure SQL DB world, when I actually do the commit, so now you have like, okay, secondary replicas and there is a geo replica. This is to ensure that, okay, high availability and redundancy. So when I do a commit, it basically does a quorum commit, and the quorum needs to like send a signal back saying like, yeah, the data is safe, I have committed, now you can go ahead, right? So this takes a little fraction of extra milliseconds in order for the quorum to acknowledge the things. So our applications are like, okay, really workload intensive. For example, when I'm trying to run a manufacturing planning, so we call it as MRP, and doing like millions of inserts is not uncommon. So if you're just going to commit every time I just do an insert, and so this extra few milliseconds and microseconds that I spend on this commit acknowledgement, that can add up, and that can be like, okay, as much as 20 minutes to the entire process. So we have to just make sure that, okay, we optimize our application. So we pretty much removed all the auto commits, and we bulked up at the logical points where we have to commit it, and that improved our performance. So this is a good practice as well. So whether we are going to Azure or not, Azure SQL DB or not, but the point is like, okay, since we moved to Azure SQL DB, that compelled us to just make these optimizations. The other thing I wanted to touch upon is, since it's a mission critical application and lots of departments working, let's say like, okay, I just run a batch process to handle a financial report. And if it picks up a bad query plan or something and it started consuming all the resources, then my delivery clerk who's waiting there, he may not be able to print the packing slip he wants, right? And somebody who's trying to create a sales order, he may not be able to post it because the machine is busy, the SQL is busy, and it's pretty much running out of the resources. So in the on-prem world, we have an option for the customer had an option. They can use the resource governance that was available like since 2008 or before, and they can use that to control the workloads. So when we went into Azure SQL DB, the resource governance were no longer available. So we have to just find a way to like, okay, address this particular one. And we thought about quite a lot, but the best way we could use is like, okay, having the resource governance feature that's available on the SQL. So we went and requested the SQL team to just, the importance of the resource governance in our scenario, and asked them to just provide this particular one. So SQL created a private, so resource governance in the Azure SQL DB. It's in the private preview, but we are taking full advantage of that.
So Gana, let me make a quick point. So we work very closely with Gana's team, but I think the point I want to make to you is that we, as Azure database is being picked up, 5 million deployments of Azure SQL database with customers, as with the telemetry, we figure out what are the common problems being faced by our customers. We want to respond to those problems in a very, very timely fashion. And this resource governor issue that you pointed out, Gana, this was also raised by many other customers, and it was a good opportunity for us to trade. So we are able to respond to these blockers in a very timely manner.
Yeah, exactly. So I wanted to really appreciate the SQL team here because it's a partnership, and this is really something that, okay, we really needed because we wanted to ensure the customer doesn't face this particular problem. And we were quite thankful for the SQL team to just providing that as with the resource governance feature. So in this diagram, basically, I was just trying to show like how AX using this resource governance feature. So we have multiple workloads. The top, you have a batch workload, and in the second cell, I'm just showing like we have an online workload. And the third is like a default workload, which is like all the others. But in fact, like now we have other workloads too. Like, okay, we have management reporter, we have integrations. All this we can classify as different workloads. Now I can just set min and max for each workload, right? So for example, my online user who's just waiting there and doing something interactively, I wanted to just make sure that, okay, they get the best response as possible. So I don't want them to starve for SQL resources. So in that case, like I will give them the maximum priority, and I'll give them like, okay, so a certain amount of like, okay, resources. I'll guarantee them as much resources as possible, right? By just lowering the thresholds of the others based on the priority. So for example, if I'm just going to run an integration, the integration could be a job that if it's going to take another extra 10 minutes, in customer's case, if it is fine. So we don't want them to like interfere with the online user. So with the proper adjustments of the min and max for each resources, now Dynamics 365 F&O is able to like control its resources and provide the resources needed where it is really required. The other challenge that we faced is with the TempDB, TempDB implementation that was offered with Azure SQL DB when it was originally available. So in TempDB, SQL offers like two kinds of temp tables. One is like a pound temp tables, which is like, okay, session specific. As soon as I close my session, the temp table disappears. And the other is like, okay, a global temp table, which is pound temp table. So I can create this pound temp table. I can open another session, and I can refer the temp table that's been created by another session. And as long as the table, the session that's created, the temp table, as long as it stays up, and the other sessions can use this. So we were already using this pound temp table because it was available for a long time in SQL Server. So when we went into Azure SQL DB, it was no longer supported. So we have to find an alternate, and we found other implementations for changing this implementation. After some time, like recently, they started supporting the pound global temp tables also now. But like, okay, so our journey was started way back, and we changed some of our implementations to not use the global temp tables. The second one is like the three-part references. So this has been removed in Azure SQL DB. So Sunil mentioned in his presentation that, okay, when the customer has multiple databases and they were trying to access the data from multiple databases in their queries, most probably they will use like the three-part naming conventions to refer to a table that is part of another database. It's a very similar thing. I'm trying to refer an object on the temp DB. And AX was fully using this particular one. Now, when we went to SQL Azure DB, when they removed this feature, support for this particular feature, now we have to find an alternate. So what we did, we actually started creating these temporary instance of the tables in the AX database itself, right? That's our primary business database. There are few pitfalls with that particular approach. One is TempDB has the logging level at the TempDB is very different than logging level at the business transaction databases. So here, everything is logged, detailedly logged. It has to support both roll back and roll forward. And also like, okay, everything I create here and commit here, that will get replicated into my secondary, and it will get replicated into my geo-replica and everything, right? So these are the temporary table. I'm using it as a scratch pad, and I'm creating the data, and I don't want them to be like, okay, I don't really need them. So this, at the end of the process, I'm going to truncate them because I'm just using it for my process and to make my process very efficient. But since we didn't have an option, we moved them to the business database, and in effect, what we ended up with is like, we ended up having additional overheads. So, and I'm sure like, okay, so if managed instance kind of a facility that was available at that particular point of time, so then we don't have the same challenge. So we could have, the managed instance would support that three-part naming convention, and we don't have to like, okay, just go and find an alternate which is not that superior to start with. So, and there are other alternates that we tried, like, okay, we try to use the memory optimized table, which we call it as a hackathon tables, and we use like stripe to work tables. So, but none of them really panned it out. So, but the future is like, okay, as I was just saying, we talk to SQL team, and SQL team also like, okay, look at their use, people's usage using their telemetry. So we convinced them that, okay, we really need a really global instance of a temporary table. So not only they provide that global temp table, support to the global temp table previously, like, okay, a year back, now they also extended the life of the global temp table. So now in Dynamics 365 F&O in the future versions, not in the future version, the very immediate updates, we will start using this functionality, and we will start creating this global temp tables in the TempDB, and it's going to, like, okay, improve our performance and scalability quite a bit. So it's a kind of a journey. So SQL is a trusted partner for us, and they constantly trying to, like, okay, just provide us, improve the applications, workloads, and this is one of the examples where, like, continuous improvements are happening, and this is paying us dividends because we are on the Azure SQL DB. For example, this is a kind of a feature that's needed, and on the on-prem world, then we may have to wait for SQL 19 to come, because, like, till SQL 17 there is no such support, either like SQL 18 or SQL 19, so the customer has to wait. Now here it's like, okay, it is transparent to the customer, and the customer will always see this benefit. Okay, the other thing I wanted to just touch upon is, like, okay, as you migrate to the cloud, there may be other things you need to worry about. So it is not just pushing the things into the cloud. So you need, for us, it is like we need to find an efficient way to monitoring the errors, performance, and not only we have to do this for a single instance, now we are just supporting like thousands of customers. We have to do this on a scale. So what we have to do, so we have to change our applications a little bit. So we have to extend our telemetry, and so we have to rely on the query store more, and the query store is a new feature that was offered, and we just decided, okay, so this is to take full advantage of this, and we are still continuously taking advantage of the dynamic management views. And also we created new tools like Watchdog and Optimization Advisor, which in turn basically, like, okay, just goes and look for opportunities to improve, and continuously it actually updates so that, okay, we can see the benefits. So this is an example of the monitoring tooling options that we have enabled. So for example, to get a SQL insight, right? So this basically draws the data from the query store, which captures the data, and it exposes to us and to the user, like, okay, the efficiency of their system and what is happening inside their system. So so finally, I wanted to end up with some learnings. So from our journey, we found, okay, there may be some challenges, and you have to just be prepared for the challenges and look for the workarounds. And sometimes this is an opportunity to actually upgrade your process, to improve your process also. So look for these opportunities. And the second thing we were just looking for is, like, okay, the SQL database, the Elastic pool and on the SQL DB. So when we started with this particular one, we just decided we'll just go and start using singleton without Elastic pools. And the Elastic pool has a potential to reduce the COGS for us. And we are just constantly looking for reducing the cost, at the same time not compromising the perf and scalability aspect. And this is something like, okay, just go and continuously evolve. And the other thing is, like, okay, just we are looking from our side ways to use read-only secondary for scaling. So some of these options are available. So as you migrate to SQL and as you migrate to cloud, look for these opportunities, do some changes to your process wherever it's required, and at the end, you will end up with meeting your primary goal, which is supporting your customer and allowing them to just focus on their business and eliminating all the maintenance needs and other worries, and enable them to be very successful. Thank you.
Yep. Thank you, Gunnar, and thanks for joining. Let me just summarize the whole thing. So as Gunnar said, Gunnar and Bing Ads team at some level are the early adopters of SQL database for their critical application. And one of the goals for SQL Azure team is to make the migration lift and shift and manage instance is our solution for that. So our expectation is that it will be almost seamless for you to take an application from on-premise and move it to the cloud and start taking the advantage of the benefits of PaaS service. And with that, I want to close the session, and thanks for joining, and good luck with cloudification of your applications. Thank you so much.